What is this video about?
Oh, it's the one with bases.
Bases like Skrillex, like.
That was good, but no, that's not what I mean. That's not what I mean. I mean.
You mean?
Oh, the one with the ammonia.
The ammonia. So the silver nitrate forming a seeing.
Oh no, you're close, but you know what I mean. You know what I mean.
What
you know what I mean.
What you mean?
I mean.
Amines. You mean amines?
I mean amines.
Oh well, there you are. So wait, I got a question.
Yeah.
What's an amine?
Good question. I'll teach you. Taught.
Wow.
So it all revolves around the idea.
So much quicker.
Of this ammonia. So it's attached.
We have an ammonia. It's a bit bigger than what I've drawn up there. There it is. It's in 3D. We'll talk about that in a second. So that is not an amine.
No, but it revolves around that idea.
So what happens is we have three different types of amine. We have primary, secondary and tertiary. And in each of these, one hydrogen is removed and an R group, which could be anything, is replaced. Apart from hydrogen. So in primary, one hydrogen is replaced by an R group, which could be a methyl or a bromine thing. And in secondary, two hydrogens are replaced by two R groups. They don't have to be the same R group. They could be, like, one could be a benzene ring, one could be a halogen or whatever. And in tertiary, all three hydrogens are replaced with different or the same, what doesn't matter, R groups.
So we said we'd come back to it. Let's go back to it.
All right.
Is these wedges. So if it's this, it's normally filled in completely black. Means it's coming out towards you.
Yeah. I sort of think of it as a spear, like that.
That's a good way to think of it. The dashed line means it's going into the planes. This will be going into the whiteboard or into your exam paper.
And the normal lines are just sort of in the same plane as your whiteboard, exam paper, or just textbook.
We did do this at AS, but now you actually need to fully know it.
Yeah.
And it might be you might have to be asked to quote it. And as Trev's explained, this is primary, secondary, and tertiary amines. So now we know what amines are. Let's do more about amines. So firstly, where are they used?
Well, they're used in lots of things. When they're used in Lemsip, they're well tasty. And lots of things you get over the counter in pharmacies.
Like congestion pills and cough syrups.
They're also found in something quite badass.
Something I love. It's one of my favourite uses of amines.
It is, and it's adrenaline.
Yep. The fight or flight thing.
Which is used for you to make sort of shock decisions, which is pretty handy. So amines are good for that. And also really good at smelling like fish.
Yeah, they do all have a particular aroma, most of them smelling like fish.
But we don't just call them fish smelly things like trout, salmon,
Jim, Bob, Jimmy Bob,
Bobby Jim.
We have to actually have a naming system in place, so
let's get on to that. So we have primary ones, which sort of follow a list that you would understand, well, you'd understand a little bit, but makes the most sense.
So you've got NH2, the third H has been replaced, that's what makes it a primary.
Yeah, and this is Wayne's favourite amine, as I now know, see a brain thing. It's called phenyl amine, because it's a bit like phenol, but this always happens in amines. The group it's attached to becomes yl, and it always ends in amine.
Yep, so I'll underline that. But secondary and tertiary comes a little bit more awkward, so let's draw up one of them. So
in secondary and tertiary, at least two H's have been replaced by R's. But now we're going to say what RRs are.
You can't name it if it's R. So if we say this one's just a methane added on, so it's now a methyl part.
And that bit can be an ethane.
Yep.
Alright. So
that looks like that. The things at the end of the lines are hydrogens, they're nothing special. I'm not going to draw them all along, so it'll take ages.
It'll take ages. So when you're naming chains, or whatevers, you start by finding the longest bit of the carbon chain.
And I found it.
Oh, well done, Wayne.
It's here. 2 carbons long is the longest carbon chain you can make.
So that becomes ethane, but as it's attached to an amine, it becomes ethyl.
Yep. And it still ends in amine. I've underlined it here as the important bit. The yl and the amine. So it's ethyl amine is the end of the name. You're now treating this a bit like a central carbon, but it's a nitrogen.
Yeah.
So that makes this a side chain.
So as a side chain, it'd be a methyl group.
Yep.
So it is methyl.
And that goes in front of the name, like when you're naming normal organic compounds, but rather than a number, you'd normally put a number, like if you have an OH on a second carbon, it's 2-ol.
Yeah. But here, it's just attached to one nitrogen, but there's only one nitrogen, so it makes sense for the number.
To be one methyl. So what we do is we say it's N-methyl.
Yeah.
Attached to N.
So then we go on to tertiaries.
So
the N bit sort of becomes a bit clearer what they do often.
Yeah. So
if
if it's another CH3.
Sure. You sort of treat them separately. So to start with, there's 2 of them, so it'll be dimethyl.
Yeah. So that's the same as your other organic things.
Yeah.
But in terms of the numbers, which we said was N,
we sort of treat them separately. So you have one lot of N-methyl, so you have N-methyl, and then you have another one, So there's another lot of N-methyl. So you have
So it's twice.
N-methyl.
Dimethyl, ethyl, amine.
Which is
would say the whole
a great
thing.
name. So if we then change this to something like a halogen, let's go for bromine.
Let's go for bromine. And what you have to do is, firstly, this di is going to be getting rid of because there isn't 2 anymore.
No, and also alphabetically you start with bromine.
Exactly, so this is still N-methyl, and in front of that, because B comes before N,
As it's attached to another N, we're going to have N-bromo, N-methyl, ethyl, amine. So the names are beautiful.
but it's not going to get any harder than this in terms of you naming it.
Yeah.
So we've pretty much summarised that quite well, I think.
Ta-da. Well done, guys. Alright, nice one, team. Anyway.
So we know that ammonia can work as a base because of the lone pair on the nitrogen.
Do, and basically aiming to do the same thing.
Yes. So they can react with acids to form a salt, but they don't make the water.
No, they're not. Well, I guess they are thirsty because the water disappears, maybe.
Yeah.
Whatever you want to think of it. But no water is formed. So we take Wayne's favourite one, phenylamine, and we react it with an acid.
HNO3 is a good one.
Alright, there's lots of nitrogens everywhere. As an acid, it will donate a hydrogen.
Which is going to attach to here and
Yeah.
make it NH3 plus.
Because what makes it act like a base is the lone pair on the nitrogen, which then forms a coordinate bond with your hydrogen.
Yep. But that's not yet a salt, because it doesn't have a positive and a negative.
So a negative becomes the minus NO3, or NO3 minus, sorry.
NO3 minus.
And that is your new salt. There you are.
Absolutely, so that's a property of amines. They can take place in base reactions.
So we know what they smell like, we know what they look like, we know how to name them, but we don't know how to make them, Wayne.
Not yet. So there's two of them.
Yeah.
There could be aliphatic and aromatic.
So a quick recap of what that is. We did it earlier in our series, but you'll say it again. An aliphatic is just a straight chain molecule.
Yep. Aromatic is when it contains a benzene ring.
Yeah.
So we'll go through aliphatic first.
Alright.
That means it starts off with a straight chain thing that isn't an amine, and we can turn it into one.
Yeah. So it starts with a chloroalkane or a halogenoalkane, but we're going to go for chloropropane.
Again, these are all hydrogens, nothing special.
Yeah. And what we add to it is we add ammonia.
We do indeed add ammonia, so that's going to attach, but when it attaches, because there's this double bond, this lone pair, it can displace the chlorine, but it can only take 2 of the hydrogens with it. So it has to make the choice and leave a hydrogen behind.
And it does that. Poor hydrogen.
Nitrogen doesn't really care,
No.
as long as he's happy.
So we are left with our group, but now it's an amine. And at the end we have a hydrogen and a Cl, and they bond in a sort of beautiful relationship.
Yeah, because the Cl's been ripped off, that's where that came from. And the H has been left behind, so HCl is formed, and I've heard that they're still together to this day.
Oh, isn't that beautiful?
I love it when it turns out well.
Yeah. But there's a problem.
There is indeed a problem.
And it's not.
This is an acid, and that picture's on a slant.
I'll just sort that out for you, Wayne.
There's another problem though. That's an acid, and this is a base.
Oh, you're right, Wayne. So they'll react, and you'll run out of your base, and then bad stuff will happen. If this runs out, then your chain here and your straight chain here, they'll react and form something monstrous.
And we don't want that to happen.
We don't.
Because that would be really horrible to name. So, what
to
we
avoid
do-
this, we have a large excess of ammonia. Because this reaction will only happen if this runs out and should be used up by the hydrochloric acid to form this.
You can't stop this reaction happening unless you suck all the HCl out somehow.
And it's not, you
That's
can't do that. There's not a magical HCl magnet, but if there is, I want one.
So if you make this in excess, then this can do this reaction and still have enough left over to react with this, hence stopping this reacting with this.
Problem solved.
Yep, and then you won't have to name anything horrific, so that's good.
Alright, cool.
Aromatic though, this is it for aliphatic.
Yes, that's all you have to know.
You don't need to know the
So-
mechanism of it replacing the Cl.
No, you just need to know that it happens like that. So, aromatic, sorry, you are forming one of benzene rings. You start with a benzene thing, you start with nitrobenzene.
Yep, and you want to make it into an amine, so
You do.
it'll be phenylamine is what we'll produce if this is an NH2.
Mm-hmm.
So what we can do is we can bribe the oxygen away by giving it a present, and inside that present is a hydrogen.
That's a lovely present, but what It's actually there as a reducing agent.
Yeah.
So the reducing agent in this case is a mixture of HCl and tin.
Yep, tin, not very often a thing in chemistry for catalysts,
But in
so
this
it can be
case,
quite hard to forget. And HCl, yeah.
yeah, that is a thing. But for balancing, it's actually quite useful just to think of this as just one hydrogen.
Yeah.
In this case.
So we know what we're going to end with.
Yeah, we're going to end with our phenyl amine. So that means that we are 2 oxygens have left, and well, we got hydrogens from our hydrogen thing here.
The oxygens are going to be replaced one by one in the actual thing, so it's not likely that it's going to form oxygen as it removes one, because there's lots of hydrogens that's going to bond with that. So it's going to make water.
It is going to make water, and as there's 2 oxygens, it's going to make
2 waters,
2
otherwise
waters.
the oxygens won't be balanced.
But then to balance the rest, you have to see how many hydrogens you have on this side, which is 6.
So you need to put a whapping grade 6 in front of the hydrogen there.
And that's that really.
And that's aromatic.
Yeah.
Yeah, that is aromatic.
Ta-da. So now you've made your aromatic things. So now we get on to our next juice, which is dyeing.
It is indeed. It's not as sad as it sounds.
It's not, because Wayne wants blue hair, don't you, Wayne?
I do want blue hair, I think that'll be great.
I think that would be great. You look like Sonic the Hedgehog.
I
So
would
to
look like that.
do that, we need a dye. We can make a dye out of an amine.
And this is the only mechanism that's ridiculous for amines.
It is quite large. It takes place in 2 stages. First you need to create a diazonium ion, then you need to do a coupling reaction. So, we're going to start with the yeah, it's a process. We can spell it, but we can't say it.
So you've got your NH2, which if we've got it attached like this, it's a phenyl amine.
Yeah, we've got
which
that.
we've just produced. We know how to do
We
that.
know how to make that. So now we've made that, we need to react it with a couple of things. And a couple of things are hydrochloric acid and nitrous acid, or nitrous acid.
Nitrous acid.
Which is not something that appears everywhere.
It's not.
HNO2.
So you need to know how to make it. Yes, it is. Sorry about that.
That's alright. I forgive you. So this is unusual, so you have to work out, well, no, you have to know how to make it. So, then we little arrow off.
A bit of weird.
I know. So we form it with sodium nitrite,
Yep.
which is NaNO2, and
HCl, which everyone has plenty of.
in their cupboard, always.
And it's going to do the simple exchange, as it were. So it's
Yeah.
going to make your HNO2.
Which is what you want, and then it's also going to form
Salt for
your
your
salt.
chips.
Yeah, I wouldn't recommend it on your chips just in case anything's gone slightly wrong.
And that's how you form it. You need to know that.
So, now you've got your reagents, you need to react it. Now, there is conditions this happens under.
You're absolutely right with that. I'm going to do that in red as well.
Okay, so it only happens below 10 degrees Celsius.
T is the temperature. Has to be less than 10 degrees Celsius. That comes up time and time again.
As is this big amine thing, because it's pretty much the only hard bit in amine, so learn it.
Good luck with that.
So, now it's happening, so stuff happens. That wasn't very helpful, was it? But we form quite a mean looking thing, a diazonium ion.
What I like to do is I like to think, I know what this part's going to look like, I just remember that it's this. So if I were you, I'd try and remember that bit.
Yeah.
Then the rest of it, I like to logic out each time. You can just remember the entire thing, or you can try and logic the entire thing, but I find that quite difficult. So what's going on is this nitrogen is bonded to another nitrogen. The only nitrogen it can bond to is that one. So if these nitrogens are going to bond together, it must have lost this oxygen and this hydrogen. They've both gone. And this nitrogen must have lost this hydrogen. That's all gone.
Yeah. And the Cl has been displaced from the other hydrogen.
To make this ion.
Yeah, so then the hydrogen there must have gone as well. So what does that leave us with, Wayne?
Well, what it leaves us with is 1, 2, 3, 4 hydrogens and 2 oxygens, which I make to be 2 waters.
Which is pretty handy.
And that's what's going on at this stage. This diazonium ion has to be formed.
So you've formed that there. Now we're not finished. Next stage is a coupling reaction.
Which is a beautiful relationship between 2 hideous chemicals.
It's like a love story. The theory of chemistry, I suppose, to everything.
Yep.
So, coupling, if you're sort of getting what you're doing, I like thinking of 2 of these, so these 2 things end up together. But first you need to know what you're reacting with, so you react your diazonium ion with some phenol.
Yep. And
And
sodium hydroxide.
Yeah, the entire coupling reaction takes place under alkaline conditions.
So they actually write sodium hydroxide twice like this.
Yeah.
That's how they express it. Because essentially the NaOH is in excess so much that it makes the whole conditions alkali and the NaOH itself reacts.
Yeah.
So they write it twice normally.
For fun.
Just to mess up with your head, really.
So as a coupling reaction, we're going to put together our two benzene rings, but not just attaching to each other.
No. They're going to be really, really jazzy.
They are. What's going to happen, essentially, is we're going to break the triple bond.
This isn't stable as it is. This nitrogen here, at the minute, has got 4 bonds, and nitrogen can only make 3. So this nitrogen's fine with it, but this nitrogen's getting really angry.
Yeah, it's not happy about it at all.
So straight away we can see what this Cl can react with in this whole equation is the Na to make salt. So that's going to be a product.
Right at the other end.
So that's this reacting with this to make a neat little product.
Yeah, more table salt for your chips.
Now, because even with that gone, this is still going to have 4 bonds and it only wants 3. But what can happen, because this is so unstable, is that you're going to have this phenol, that's not going to change.
No, it's just
like
going to be
that, bonded to
chilling.
the N. But then if that N is only double bonded to the other N,
then it will form a little group in the middle, and then this bit is still attached to your other.
this bit can then attach
benzene
to
group.
the other phenol. So this N is now attaching to this phenol to make this one more stable. So now they've both got 3 bonds. Now this phenol has hydrogens all over the edges, if you think of how many bonds each carbon can make. So for this N to attach to it, it must have displaced a hydrogen. And there's an OH here, which is going to make our lovely friend water as well. And that's all of your products. Now what Triv's labelled there,
That's called a diazo group, because the azo bit is the nitrogen and the phenol thing. So your diazo group is the middle of your azo dye.
yep. And this whole thing is a colourful thing that can be used to dye your hair.
Probably.
Probably.
And that's quite a hefty reaction.
Remember alkaline conditions.
Yeah,
That's always a mark in this, and everyone forgets it.
Yeah,
because it seems
conditions
obvious.
throughout all mechanisms are very important to remember. Because anything you're going to forget, 'cause you'll do the mechanism lots of times, but the conditions, that's something I forget.
An alkaline is a mark in itself, just the word alkaline. And if you're 1 mark off the next grade, and that mark is saying the word alkaline, you'd be kicking yourself. So there you go.
Don't do that. So now we've done the big dye reaction, that leaves us with only a reaction left in life.
It's the most important one.
It is.
It's just like this. Dyes.